Hello and welcome. Today we are talking about contingency tables. Contingency tables represent an alternative way to organize information in a very similar way to a Venn diagram. So basically the way this is going to work is that we're going to take the sections of the Venn diagram and use those to fill in the numbers based on the labeling of the rows and columns. So as an example, I look at my Venn diagram and see that there are 12 students taking both marching band and Spanish. So I go over to my contingency table and place a 12 in the box where marching band and Spanish overlap. We then fill in the rest of the numbers the same way. So there's 13 students that take Spanish class only, so they are not in the marching band. There's 11 students that are only in the marching band, so they do not take Spanish. And then we have these 4 students over here that are not in either. We can then add across to get our totals for each row, add up and down to get our totals for each column. And if we've done this correctly, the totals for each row and column should come out to 40. So 23 students in the marching band plus 17 not in the marching band gives me 40 total, which matches with the 25 students taking Spanish and the 15 not taking Spanish, also adding to 40. So it looks like all of our numbers here are correct. Next thing we need to know is how to find frequencies on our contingency tables. As we've mentioned before, frequency means the number of times a certain event occurs. So when we see a joint frequency, that's referring to the number of times that 2 events occur at the same time. And then a marginal frequency represents the total frequency of each row or column. So when we're looking at our contingency table, the joint frequencies are going to be the numbers in the middle where the categories overlap with each other. And our marginal frequencies are going to be the numbers in the total section for each row and column. The term relative frequency refers to the ratio of a given frequency to the total number of data points. For our purposes, basically just think of that as the same thing as probability. So to calculate our relative frequencies, we're just going to take each number in the table and divide it by 40. So after dividing each term by 40 and then reducing the fractions when possible, our contingency table now looks like this. So if we were asked to find the relative frequency or the probability that someone in the marching band does not take Spanish, we would say 11 out of 40. If we were asked for the probability that someone takes Spanish class, we would add these up and get 5/8, so on and so forth. So here we have a contingency table with students' desired superpowers and the number of pets that they have in their household. We are asked to find the probability that a randomly selected student has no pets. So we're going to go to the row where it talks about having no pets, and we're going to take that total and find the probability. So we set up our fraction as 15 out of 40 and then reduce to get 3/8. We can then use the same data to find the probability that a randomly selected student has 1 pet and wants telepathy as their power of choice. If we refer back to our table, we'll notice that the row for 1 pet is here. The column for telepathy is here. So there are 5 students that want telepathy and have 1 pet. So we'll set up our fraction as 5 out of 40, which can then reduce to 1/8. Next, we'll find the probability that a randomly selected student has more than 1 pet or wants invisibility. So since this says or, we're going to include any student that fits at least one of the conditions. So we're going to include all 11 of the people that have more than one pet, and then add in the 7 people over here that want invisibility. The trick is to remember that just like with Venn diagrams, we need to be careful not to double count anyone. So the 3 people here belong to both sets. Therefore, we only want to add that 3 in once. And so when we want to find our answer, we can either take the total of the first row, which is 11, and then add in the boxes for the ones we need to include on top of that. So it'd be 11 plus 2 plus 5, which is 18 out of 40. Or we add the totals from the rows and columns that we want and subtract the box that got counted twice. So 11 plus 10 minus 3, which also gives us 18 out of 40. So either way, our answer is 9 out of 20. And then for our last example, we will find the probability that a randomly selected student has no pets given that they want to fly. The trick to this one is remembering that the word given restricts our sample space to only the second condition. So for the purposes of this question, we are only focusing on that first column. Any number outside of that doesn't matter. So for the purposes of this problem, the 7 students in this box right here are the only ones that we are concerned with. So when we set up our probability, we will take the 7 from this box right here, use the 14 as our sample space, and then reduce the fraction to get 1/2. And that's all we have for this one. I'll see you guys next time.